沈阳 WS-15 发动机的历史、现状与未来综述。发展历程。早期研发阶段，1990年代2005年，沈阳 WS-15 涡扇15发动机的研发始于1990年代，旨在为中国的隐形战斗机提供一款高性能的动力系统。2005年 WS-15 在实验台上成功测试，标志着其技术发展的重要里程碑。首次亮相与推力提升2006年至2012年。2006年 WS-15 首次在中国国际航空航天博览会上展出。到2009年，原型机的推力达到了160千牛，约36000磅。随后2012年 WS-15 的目标推力又提升至180千牛，约4万磅，力求进一步提升战斗机的性能。飞行测试与量产2022年至2023年。据报道，2022年 WS-15 在成都 J-20 战斗机的测试中表现出色，完成了多次试飞。2023年3月，中国航发公司宣布 WS-15 的量产已正式启动，标志着其克服了所有技术瓶颈。同年6月，媒体报道称，可能装备双 WS-15 发动机的 J-20B 战斗机在成都成功完成首次飞行。当前状态。截至2023年 WS-15 已进入初始生产阶段，且在 J-20 战斗机上的应用逐渐成熟。WS-15 的成功量产不仅增强了 J-20 的作战能力，也意味着中国在高性能喷气发动机领域的自主研发能力得到了显著提升。性能与优势。WS-15 的设计目标包括实现超巡航能力，增强 J-20 的可靠性、机动性和燃油效率，同时提供更长的航程和更高的电力输出。与早期的 WS-10 发动机相比， WS-15 在推力上有明显优势，预计能将 J-20 的综合性能提升到与美国 F-22 相媲美的水平。技术参数。最大推力 161.86 至180节36 39040 470 lbf， 总压比 25-26， 旁通比 0.25， 涡轮进口温度 1850 K 1580摄氏度，推重比大于10。未来展望。随着 WS-15 的进一步发展和成熟，中国的航空发动机技术得到了显著提升。未来 WS-15 不仅将提升 J-20 的作战能力，还可能使其在国际战斗机市场上占据一席之地。同时 WS-15 的成功也标志着中国在高性能喷气发动机领域的自主设计与制造能力的提升，改变了中国长期依赖进口发动机的局面，并为未来的航空航天发展奠定了基础。不同来源的观点。维基百科提供了 WS-15 的详细设计与发展历史以及技术参数的概述。John D. 讨论了 WS-15 是否能挑战美国在战斗机发动机技术方面的主导地位，并关注其对全球军事力量平衡的影响。TWZ 专注于 WS-15 在 J-20A 上的实际应用，展示了最新的飞行测试照片，并探讨了其对中国航空力量的意义。事件时间线。1990年代 WS-15 的研发开始。2005年，发动机在实验台上成功测试。2006年，在中国国际航空航天博览会上首次展示。2009年，原型机推力达到160千牛。2012年，推力目标提升至180千牛。2022年3月 ，J-20 测试中报告 WS-15 表现出色。2022年12月 ，WS-15 进入最后测试阶段。2023年3月 ，WS-15 量产启动。2023年6月 ，J-20B 可能装备 WS-15发动机首次飞行。通过以上信息整合，可以看出 WS-15的研发和应用不仅是中国航空工业的重大进步，同时也可能对全球航空技术的格局产生深远影响。随着 WS-15的投入使用，中国的航空力量正在不断增强，未来在国际军事舞台上的影响力也将随之提升。Counterintuitive information in the content on Shenyang WS-15. Performance expectations versus reality. While the WS-15 is designed to provide capabilities comparable to the F-22, there are questions about its fuel efficiency and maintenance requirements. This raises a counterintuitive point. Even though the WS-15 offer higher thrust and supercruise capabilities, the overall operational viability could be hampered by these factors, suggesting that raw power does not always equate to superior performance in operational contexts. View technological maturity versus historical dependency. The text emphasizes the significant advancements made by China in developing the WS-15, portraying it as a leap in domestic aerospace capabilities. However, it also acknowledges that a major portion of China's earlier military aviation capabilities relied on Russian technology. This juxtaposition suggests that despite the advancements, there remains a historical dependency on foreign technology, challenging the narrative of complete independence in military technology. 3. Assessment of threat level. U.S. military officials have downplayed the threat posed by the J-20, even with the introduction of the WS-15 engines. This counterintuitive stance suggests that even as China appears to advance technologically, the perception of threat may not increase correspondingly. This indicates that technological advancements may not necessarily change geopolitical dynamics or threat assessments in the immediate term. 4. Public perception versus reality of development. The timeline of the WS-15's development, which began in the 1990s and only achieved initial production in 2023, highlights a disparity between public expectations of rapid technological advancement and the reality of lengthy development cycles. This can counterintuitively suggest that advancements in military technology are often incremental and fraught with challenges, contrary to the belief that cutting-edge technologies are developed rapidly and without setbacks. Why focus on thrust versus overall capability? The discussion around the WS-15 emphasizes its thrust capabilities compared to the WS-10 and F-22. This focus on thrust may lead to an oversimplified understanding of what makes a fighter jet effective. Factors such as avionics, stealth, and tactics are equally important, suggesting that thrust alone does not determine the overall combat effectiveness of the J-20. Liu's perception of competitiveness. Articles discussing the WS-15 often suggest that it may enable the J-20 to compete more effectively with Western fighters. However, the complexities of aerial combat and varying mission profiles mean that having comparable engines does not guarantee competitive advantage. This points to the counterintuitive idea that technological parity does not inherently lead to strategic advantage in military engagements. Qin visibility and secrecy. The emergence of images and reports about the WS-15 and J-20 development is noted, suggesting a level of transparency in Chinese military advancements. This contrasts with the expectation that a country developing advanced military technology would maintain strict secrecy. The relative openness could indicate a strategic choice to project strength, countering the typical narrative of military secrecy. In summary, while the WS-15 represents a significant milestone for Chinese military aviation, the context of its development, operational implications, and geopolitical assessments reveal a range of counterintuitive insights that challenge simplistic narratives of technological superiority. The Shenyang WS-15 engine represents a notable advancement in China's aerospace capabilities, particularly in the context of its military aviation sector. While the report provides a comprehensive overview of the WS-15's history, current status, and future implications, there are several key aspects that are often overlooked but hold significant relevance. Historical context of development. The WS-15's development timeline spans several decades, starting in the 1990s. This long duration is often minimized in discussions that focus predominantly on recent advancements. The prolonged R&D phase highlights not only the technical challenges faced by Chinese engineers, but also the strategic importance of developing a domestic engine capable of meeting the demands of modern combat aircraft. The historical context underscores the evolution of China's aerospace industry as it transitions from reliance on foreign technology to indigenous innovation. Significance. Understanding the historical context is crucial because it reflects China's broader strategy to achieve self-sufficiency in critical technologies, particularly in defense. This shift has implications for global military balances, as it indicates a diminishing dependency on foreign military equipment. Technical specifications and competition. The WS-15's specifications, such as its thrust-to-weight ratio and maximum thrust capabilities, are impressive when compared to its predecessors and even some Western counterparts. However, the report may understate the implications of these technical specifications in a competitive landscape. For instance, while the thrust rating of 1 pounds is highlighted, the potential for supercruise capability and improved fuel efficiency could provide the J-20 with operational advantages over rivals like the F-22. Significance. The technical specifications not only impact the performance of the J-20, but also represent a critical factor in the global aerospace race. The ability to supercruise without afterburners, for example, can lead to extended operational ranges and reduced heat signatures, which are vital in modern combat scenarios. Impact on international military dynamics. The report touches upon the potential of the WS-15 to alter the balance of military power, particularly in relation to U.S. dominance in fighter jet technology. However, it may not fully explore how the introduction of the WS-15 could embolden China's military posture in the Asia-Pacific region and beyond. The integration of advanced engines like the WS-15 into the J-20 could enhance China's deterrent capabilities and influence regional security dynamics. Significance. This aspect is essential for understanding geopolitical implications. A more capable J-20 could lead to increased assertiveness in territorial disputes, prompting responses from neighboring countries and the United States, thereby affecting the overall stability of the region. Indigenous innovation and economic implications. The WS-15 is a product of China's push for indigenous innovation in aerospace technology. This drive not only speaks to national pride but also has significant economic implications. The development of advanced engines like the WS-15 can foster growth in high-tech sectors, create jobs, and contribute to the overall advancement of China's technological landscape. Significance. The economic ramifications of such technological advancements are profound. They can lead to enhanced national capabilities, a more robust defense industrial base, and increased competitiveness in global markets. This economic aspect is often overshadowed by military discussions but is crucial for understanding the broader impact of defense spending on national development. 4. Challenges and future prospects. While the report highlights the progress made with the WS-15, it may not adequately address the challenges that remain. Issues such as maintenance, reliability, and the sustainability of production processes are critical for long-term operational success. The transition from prototype to mass production is fraught with potential pitfalls, including scaling manufacturing capabilities and ensuring quality control. Significance. Recognizing these challenges is vital for a balanced assessment of the WS-15's future. While the initial production is promising, the path to operational readiness and reliability in the field is complex and involves significant risks. Understanding these challenges can provide insights into the future trajectory of China's military aviation capabilities. 6. Regional and global reactions. The report does not delve deeply into how other nations, particularly those in the Asia-Pacific region and NATO allies, are likely to respond to the advancements represented by the WS-15. The emergence of more capable Chinese fighter jets could lead to an arms race in the region, prompting countries to enhance their own military capabilities in response. Significance. The geopolitical landscape is dynamic, and the reactions of other countries to China's advancements can lead to shifts in alliances and military strategies. Recognizing this aspect is crucial for comprehensively understanding the implications of the WS-15 on international relations and security strategies. Conclusion. In conclusion, while the WS-15 engine is a significant milestone in Chinese aviation technology, the broader implications of its development extend far beyond mere technical specifications. The historical context, competition dynamics, potential geopolitical shifts, economic impacts, ongoing challenges, and reactions from other nations are all critical aspects that warrant attention. Understanding these elements can provide a more nuanced view of what the WS-15 means for China and the global military landscape. 1. Developmental milestones and technological advancements. The Shenyang WS-15 engine's development journey illustrates significant milestones that underscore China's growing capabilities in aerospace technology. Beginning in the 1990s, the WS-15 underwent rigorous testing, achieving critical performance benchmarks such as a thrust of 180 kilonewtons approximate 4,000 pounds. The successful transition from prototype to initial production in 2013 highlights a pivotal moment for China, showcasing advancements in domestic manufacturing and R&D. This trajectory not only emphasizes the WS's role in enhancing the Chengdu J-20 stealth fighter's capabilities but also positions it as a significant player in global aerospace engineering, challenging previous reliance on foreign technology. 2. Performance and strategic advantages. The WS-15's design goals revolve around achieving supercruise capability, enhancing maneuverability, and improving fuel efficiency, which are crucial for modern aerial combat. The engine's thrust-to-weight ratio exceeding 10 signifies a leap in performance, potentially allowing the J-20 to match or exceed the capabilities of comparable Western fighters like the F-35 Raptor. This enhancement directly influences the operational effectiveness of the J-20, enabling it to execute missions with greater speed and agility while carrying a heavier payload. The implications of these advancements extend beyond technical specifications, as they contribute to a broader strategic posture for China in the context of aerial warfare. 3. Global implications and military balance. The WS-15 engine's introduction is poised to alter the landscape of military aviation. Analysts speculate that its capabilities could challenge the dominance of U.S. fighter jet engines, thereby shifting the balance of power in the aerospace sector. As the WS-15 provides the J-20 with enhanced performance, it may compel other nations to reassess their own military aviation strategies and technology investments. This potential shift could lead to an intensification of competition in the aerospace domain, reshaping not only military tactics but also alliances and defense policies globally. 4. Future potential and industry impacts. The maturation of the WS-15 signifies a broader evolution within China's aerospace industry, marking a shift from dependency on imported engines to a self-sufficient, innovative domestic production capability. Future developments could see the WS-15 evolving into an engine variant for other platforms, further enhancing China's military aviation portfolio. Increased capabilities in aero-engine manufacturing not only bolster national security but also open avenues for international collaborations and export opportunities. As China's military modernization continues, the WS-15 will likely play a central role in defining the future of air combat and technological competitiveness on a global scale. 1. The development of the F-22 Raptor. The F-22 Raptor, developed by Lockheed Martin and Boeing for the United States Air Force, is a fifth-generation stealth fighter aircraft that incorporates advanced technologies, particularly in its engines. The Pratt & Whitney F-110 engines provide the F-110 with supercruise capability, allowing it to fly at supersonic speeds without the use of afterburners. The program began in the late 1980s, with the first flight occurring in 1997 and operational deployment starting in 2005. The F-22's development faced numerous challenges, including budget constraints and technological hurdles, but it has since become a benchmark for stealth and air superiority. 2. The Rolls-Royce RB211 engine development. The Rolls-Royce RB211 is a family of high-bypass turbofan engines designed for commercial aviation. Its development began in the 1960s, facing significant engineering challenges and financial difficulties, which nearly led to the company's bankruptcy. The RB211 made its first flight on the Lockheed L-1011 TriStar in 1972 and has since evolved into various variants, powering numerous aircraft worldwide. The RB211's development marked a significant advancement in engine technology, incorporating innovations such as composite materials and advanced aerodynamics, which have influenced subsequent generations of jet engines. 3. The development of the Eurofighter Typhoon. The Eurofighter Typhoon is a twin-engine, canard delta-wing, multi-role fighter developed by a consortium of European aerospace manufacturers. The development program, which began in the late 1980s, faced several technical and budgetary challenges. The Eurojet EJ200 engines, which power the Typhoon, provide it with exceptional thrust and maneuverability, including supercruise capability. The Typhoon entered service in the late 2000s and has been continuously upgraded to enhance its capabilities and maintain competitiveness against other modern fighters, such as the F-35 and F-22. Its development reflects collaborative efforts in Europe to produce advanced military aircraft and engines. 沈阳 WS-15 发动机的历史、现状与未来展望。历史回顾。沈阳 WS-15 发动机的研发始于1990年代，目标是为中国的隐形战斗机成都 J-20 提供强大的动力。2005年 WS-15 在实验台上成功测试，标志着其技术进步的开始。2006年 WS-15 首次在中国国际航空航天博览会上亮相。随着技术的不断完善 ，WS-15 的推力在2009年达到160千牛，并在2012年提升至180千牛。2022年 ，WS-15 在 J-20 的试飞中显示出显著性能提升，进入最后测试阶段。当前状态到2023年 ，WS-15 已进入初始生产阶段。中国航发公司在2023年3月宣布量产启动，并在6月报道了一架可能装备双 WS-15 发动机的 J-20B 战斗机的首次飞行。这一进展标志着中国在航空发动机领域的自主研发能力显著提升。WS-15 的成功应用将极大增强 J-20 的作战能力。性能与优势 WS-15 的设计旨在实现超巡航能力，提升 J-20 的可靠性、机动性和燃油效率。与早期的 WS-10 发动机相比， WS-15 的推力明显更强，预计能够使 J-20 的性能与美国 F-22 战斗机相媲美。这一进步将使中国的战斗机在国际市场上占据更强的竞争力。未来展望，未来 WS-15 的进步不仅将提升 J-20 的作战能力，还可能引领中国航空发动机技术的进一步发展。预计到2030年，随着 WS-15 的成熟和优化，其在国际战斗机市场的地位将更加巩固。中国可能会将 WS-15 技术扩展到其他类型的战斗机和无人机上，进一步提升其空军的整体战斗力。预测与挑战：一、技术成熟度。随着 WS-15 的持续优化，预计中国将在高性能发动机技术上取得更大突破，这将使中国在未来的军事冲突中具备更强的空中优势。二、市场竞争。WS-15 的成功将使中国在全球航空发动机市场上占据一席之地，尤其是对发展中国家的军售可能会产生积极影响。三、国际关系。随着 WS-15 在中国空军中的广泛应用，可能会引发国际社会对中国军事能力的关注和警惕，尤其是在亚太地区的军事平衡方面。四、技术自主性。WS-15 的成功标志着中国在航空发动机领域的自主创新能力不断增强，未来将减少对外国技术的依赖。五、后续研发。中国可能会在 WS-15 的基础上继续研发更先进的发动机，如 WS-19 等，实现动力系统的多样化和高效化。结论：沈阳 WS-15 发动机的研发和应用不仅是中国航空工业的一次重大飞跃，也可能对全球航空技术格局产生深远影响。展望未来，随着技术的不断进步和国际市场的变化， WS-15 将成为中国空军的核心动力，助力其在全球军事舞台上的崛起。